Hello everyone. Today we are going to talk about beam analysis and we will use the stiffness method. So I will show you how easily you can analyze beam by using the stiffness method. All right. So let me start with okay. So this is the beam. All right. And we have the UDL, uniformly distributed load. We have 6 kilonewton per meter, and then we have 20 kilonewton per meter, another load for second member. So we have member 1 and member 2. All right, so for the member 1 we have the distance from 1 to 2, and this is 12 meter. All right, and for the second member we have second joint and the third joint, so we have the distance 8 meter. All right, and here we can see 1 3 4 2 5 and 6. All right, and they are node. All right, so they are node. So in here, the first things we have to find out the known displacement and the known external loads. Okay, so QK will be the known external loads and DK will be known displacements. All right, so how we can find out the QK and DK? All right, from this example I will show you how easily you can find out the QK and DK. All right, so for this one we have to do, we have to like each node in here specifically, like there we can first of all we can specify the numbers. All right, so we have 1 3 4 2 2 6 5. All right, so the each number we will like we can call it as the code. So this is the Y code and this is the Z code. Okay, so YZ. So we will write like this is Y and this is the Z one. All right, okay, so now what we have to do, the easy way to get the QK and the DK. So the first things, in all case we have to use the lowest code numbers to identify all the unconstrained degree of freedom. All right, so we have to find out the unconstrained degree of freedoms. All right, so we have to find out the lowest case. All right, so like the lowest code number, so in here we have the lowest code number is 1. For in this case for 2 we have the lowest code number is 2. For the 6 5 we have the lowest code number is 5. All right, so in here I will get 1. Okay, 1, then I will get 2 and I will get 5. All right, so in this case I cannot like take the 5 as unconstrained, because why? Because it is already in this side is fixed. All right, fixed, so that's why 5 is not eligible as QK. All right, so I will not take 5 as the known external loads. All right, so I have only 1 and 2. So hope you understand how you can get QK, the external loads value. All right, so now I will move to calculate the QK. All right, so okay, so this is the QK. So for the first one, you can see the first one will be 20 kilonewton meter. All right, so 20 kilonewton meter is sort of moment. All right, and the second one you will see, okay, so we have, okay, so the 2 will be in this side. All right, so that's why I have to find out the fixed end WL square divided 12. All right, so in this case we have the 6 kilonewton per meter, so this is the W. Okay, then we have the L. So what is the length is 12, so that's why I square. So this is basically the formula, and this is the 12. All right, so if we do the calculations, we will get the 72 kilonewton meter. All right, so once we will get the QK, so rest of the code will be DK. So we have the 3, 4, 5 and 6. So 3, 4, 5, 6 will be DK. I mean the non-displacement, and most of the case it will be 0. All right, so I hope you understand how to get the QK and DK. All right, once we find out the QK and DK, so we have the second steps to find out the stiffness matrix formula, and basically in here we will use the formula that already like we have. So we have this formula, this is called 12 over LE. So basically the formula will be like this. Okay, so 12 EI over L3. Okay, so this is the basically formula, but what I did, I take the EA in here. So this is like a sort of matrix functions in here we are applying. All right, so then what we have, we just find out the value for the member 1. All right, so for the member 1, you can see we have the 12 EI divided LQ, then 6 EI divided L square. So we just like plug in the value in the equation. So what I write in here, so we have in the first member length is 12. So you see in here, so in the first member our length is 12. All right, the second member we have the 8. All right, so what I did for the first member, I write the L length equal 12, and I just plug in the value, and I already got the value in here. So what I did, after getting all the value, I just plug in the formula. So I will get the all the value, and this is the stiffness matrix. So already we got the stiffness matrix. All right, so in here there are interesting point that why we write the 6, 5, 4 and 2 in this way, right? So this is very important in the stiffness matrix method. So okay, why I write the 6, 5, 4 and 2? So this is the near and near x, sorry, near y, near z, far y and far z. So how we get this 6, 5, 4 and 2? All right, so I want to show you here. Okay, for this case, all right, so we have, this is the directions. All right, so this is the arrow. Okay, so from this arrow easily we can find out the near point and the far point. Okay, so this is the near end and this is the far end. All right, so in this case we have the near end is 5 and 6. All right, so you can remember when we when we find out the the QK value, so we did, this is the y and this is the z. So that's mean this is the near y and this is the near z. So easily we can find out, and I just follow the thing, and I just plug in the value as 6 and 5. All right, for the 4 and 2, all right, so for the member 1, this is the far point. So the far point we have two code 4 and 2. All right, so what I do in here, so I will see this is the y value and this is the z value. So I put this is the far y and this is the far z. Okay, all right, so this is the way how we can write and how we can organize 6, 5, 4, 2 as near y, near z, far y and far z. All right, once we get the stiffness matrix, in the same way we will use to get the stiffness matrix for the member 2. All right, for the member 2 already we got. Okay, in the same things we will get in here. So this is in this member 2 case. Okay, for the member 2, this is the near point and this is the far point. So in here this is the near, so 4 and 2, so that's mean this is the y and this is the z and this is the far y and far z. All right, once I plug in the value in here, so I will get the K2, I mean the structure stiffness matrix for member 2. All right, so now we will go for our like third steps. All right, so in third steps, what we can do, we have to find out the structure stiffness equations. By using the structure stiffness equations, we will get the value of Q. All right, so we have the Q known and Q unknown. So Q known already we got, right? So in here we have the two formula. This is the K11, so that's mean the first column first row, du that's mean the unknown displacement, dk that's mean the known displacement, d12 that's mean the this is the first column and first first column and first row. All right, so once we get the value in here, so we will plug in the value into the formula. So what is our formula? You see, this is the Q value, so that's why I put the Q. You remember, this is the Q K Q K. All right, and this is the QU. So I have the 2Q1 sorry, QK, I mean I have two displacement, I have known external loads for the two case, so Q1 and Q2. All right, so and other Q3, Q4, Q5 and Q6. So all these external loads we don't have, so we have to find out this external load also. So Q3, Q4, Q5 and Q6. So then I have the EI, so I put the EI here as the formula, okay, from the formula. And then what I did, so we have total 6 code, so 1 2 3 4 and 5 6. All right, so 1 2 3 4 5 and 6. So what I did in here, I just used the very basic formula from the matrix. So I just I use the matrix addition. So matrix addition, so how you can matrix addition? So in the matrix addition, you can add only the same row and same columns, right? So in here you can see the first row first column, second row second column. Okay, I will show you how you can find out this value. All right, I just I want to show you for 2-3 example, then it will make easy for you to understand how you can add the matrix, and it will remain you easily to do it in futures. All right, so we have 0.5. okay, so how I get the 0.5? So 0.5 I put first row first column first row. So you can see in here the first row and first column, you see 0.5. all right, for the second one, so this is the second column second row. All right, so second column second row. All right, so I put 0.833, right? So you see the second column second row I have 0.5. all right, you see here second row second column second row I have 0.5. all right, then the same thing 2 and 2, so I add these two values 0.33333 and 0.5 in this case. all right, so I will get 0.833 and it will be in second column second row positions. all right, so once we finish the like the structure stiffness equations, we will we will plug in all this value into these equations, and we will get like this. all right, so once we get in here, so what we will do, we have to find out the displacement. all right, so displacement d1 and d2 we will find out. So you see in here, this is the 20 for the QK. okay, so QK. all right, then K11, so K11 means first row first column, so I put the 0.5. all right, you can see here I put 0.5, right? So then I have to multiply with du. okay, so unknown displacement is the d1. all right, so I put the d1, then I use the formulas plus sign. okay, and then what I did, Okay, D12. So that's means 0.21. I mean the first, in here, this is the first row, second column. All right, so I put this 0.25. Then I did dk. All right, so dk, I mean we have the non-displacement. All right, so in here I just did 20, and I just I plug in the I plug all those formula into our equations, and I get the d1, and d1 will be 87.527. Okay, in this case you will use the simultaneous equation. Okay, so by using the calculator, you can easily get the value of d1 and d2. All right, the same things I did in here. So for the second one, so I have the qk, I mean the non-external load, 72. In here you can see this is the 72. I just put in here 72. So in this case I have the k in this value, so I take 0.25, then I multiply with, okay, I multiply with d12, so 0.83, I multiply with d2. All right, and once I solve this equation, I will get d1 and d2. All right, when we will finish this, we have the step number 5. Okay, so we have the step number 5. Then in here what we'll do, we will find out the unknown support reactions. All right, so we will find out the unknown support reaction. This is the qu. So you can remember that we had only q1 and q2, right? So we find out q1 and q2, but rest of the q3, q4, q5 and q6, that's mean the unknown support reactions, we already we don't have the value. So in this case we have to find out the value for q3, q4, q5 and q6. So how we will get the value? So we have also one formula, qu k21 du plus k22 dk. So I just plug in all those value in here. You see 21 and 22. Okay, all right, you see this is the d3. So in here I forgot to mention you that we have to partition the matrix. Okay, so this is the way to do the partition of the matrix. So I will take, okay, this part, okay, because in this part I have only q3, q4, q5, q6. So I will take this part, okay, and this is the non-displacement value. Okay, so 0 0 0 and 0 0 0. So what I do, I will, okay, so q unknown, so this is the q unknown, right? So we don't know the value of q3, q4, q5 and q6. All right, so we have the ei from the formula. All right, so 21, I just I already mentioned you, I already show you that how I get this value. All right, so then what I did, I just get the value of d1 and d2. All right, so d1 and d2 value, because this is the unknown. So in here I see du, this is the value from the d1 and d2. All right, then I have the non displacement. You see, for the I have to add the non displacement. So for this is the addition sign. So in here 0 0 0 and 0, because you see we have the d3, d4, d5 and d6. In this case you see we have the 0 0 0 and 0. I just take this 0 0 0 and 0 value because this is the non displacement value. All right, for the q3, we have to, what you have to do, we will just easily follow the matrix rule in this case. So ei, okay, we multiply with this. All right, I got it right. Okay, times, okay, this is also the multiply relationships, right? So what I do, I just multiply this value and we will put the sign also. All right, this is the addition sign from the formula, you see here formula. All right, so then d22 is a 0 point negative, you see I put negative 0.00938. I have the times relationship, then I multiply with the second value, so 87.527. then I add with the 0. Okay, but if we like add the 0, it will become 0, so no problem. So from here if I do the calculations, I will get negative 7.58 kilonewton. All right, so in this case q3, okay, we have to find out the reaction. Okay, how I do the reaction, you see, come here. All right, so this is the 3, right? So we have, this is the 3. All right, so in this case, how, like, you see, we know the value, right? So if our up and down, okay, so will be the same value, right? Okay, so in this case, so that's why our reaction value is the same as Q3. All right, okay, hope you understand. Then we will find out the Q4. So using the same method, we will get the Q4. Okay, so in this case, we have to have follow one formula. Okay, because our Q4, okay, in here you see this is the Q4, right? So Q4 is related with the UDL. Okay, so related with the UDL. So what is the formula to find out the reaction at 4? So we have to times with the 6, 6 times the distance divided 2. Okay, all right, because like, we will take it as a formula. All right, and then, okay, and then we already got the R4. All right, so in here I put the upward sign. Because why I put the upward sign? Because already I have shown in here the upward reaction. All right, okay, so the same things I will follow for the Q5. So for the Q5, I have 14.59 kilonewton. So in this case, the interesting things in here, we don't have the reactions force in here, we have the momentum, right? So we have the moment in here. So how we find out the moment in terms case of UDL, I mean the uniformly distributed load. So you see here, so in this case, okay, for the 5, okay, Q5, we have the UDL. Okay, UDL, so we have the UDL is 6. So 6 times 12 is the distance divided 12. So add, okay, so we have to add the Q5. I mean, we have the external loads. Okay, so we have the external loads is 14.59. I just add the 14.59, I will get the 86.6. so our bending sign is there. So I put the same sign what I put in when I mention my notations. All right, so the Q6 will follow the same things, but in Q6 we have the UDL, but the UDL is had the fixed in, right? So we have the same formula in this case also, like R4. So I put the this is the W, I mean this is the kilonewton, 6 kilonewton per meter, I mean the UDL load, and this is the 12 is the distance, then divided by 2, and plus we will add the external loads. External loads Q6 equal 3.65. in this case, okay, I have put the I put the upwards load. So why I put the upward sign? Because already I mentioned here that the 6 code will be the upward. All right, so I think it I try my best to make the explanation easy, so you can follow this procedure to like analyze the beam in the case of stiffness method. You can use the stiffness method by to solve and analyze this problem. Thank you so much for watching my videos. Assalamu alaikum.